In this video, I'm going to start treating the tracks with effects, specifically the drums. For the remainder of this series, I'm going to be using Softube plugins. First, because I think they're some of the best plugins on the market. Second, because they're designed to provide for simple workflows, which allows me to work quickly and efficiently. And finally, because they simply sound great. That said, if you don't have Softube plugins, you should still be able to apply the same concepts and approaches to the ones you do have, including those that come with your DAW. Also, as I apply each plugin, I will discuss what the various controls do and how to use those controls to get the results I want. I'm going to start with the bass drum. There are 3 bass drum tracks, which I covered in the 3rd video of this series. I'm going to work with the kick track, which again is the mic placed inside the bass drum, since that's where a majority of the sound I'm using is coming from. One thing that's somewhat unique about the drums is the characteristics of their dynamics. For the most part, they're comprised of sharp transients or attacks, followed by quick decays. This provides for a punchy but thin sound. It also many times provides for a wide dynamic range where the loudest notes are too loud and the softest notes, like ghost notes, disappear in the mix. The most common way to thicken the sound up and reduce the overall dynamic range is to apply compression. Because of their quick transients, for drums, oftentimes the faster the compression, the better. That said, one of the fastest compressors I've used is Softube's FET compressor. To dial in the sound, I'm going to set the threshold using the input knob so the compression is taking off around 3 decibels in gain reduction. I will use a faster attack to catch the transients and a quick release to help bring up the resonance of the kick. I will also engage the look-ahead feature, which allows the compressor to compress the signal before the actual transient comes. This is a great feature for instruments with fast transients, like the drums. This combination will give me a punchy and full sound. I'm also going to take advantage of the low-cut feature, which allows me to keep the frequencies below the set value from affecting the compression, as with instruments like the bass drum and the bass guitar, the lows can eat up all the compression pretty quickly. From there, I'm going to set the ratio. This setting determines the degree to which the dynamics are reduced. For example, at a ratio of 5:1, it takes a 5 decibel increase past the threshold level to increase the output by 1 decibel. The FET compressor offers a wide range of compression settings, which I'll get more into later, but here, I'll probably go with the lighter ratio as to not overly flatten the sound. Another feature I find incredibly useful in the FET compressor is its parallel inject capability, which allows for parallel compression without having to use the compressor as a send. I found oftentimes I can achieve the most natural sounding results when blending a compressed and direct sound. As a last step, I'll apply output gain to match the input and output levels. I'll do this with the bass drum soloed, as I find working this way allows me to focus solely on what the effect is doing and dial in the settings more accurately. I'll check my work within the context of all the drum tracks after I dial in the sound. This touch was subtle, but I think as a result of it, the bass drum is punchier and a bit fuller sounding. I ended up taking off around 3 decibels in gain reduction at a 4:1 ratio. I used a fast attack and release with the low cut set right around 200 Hz, which allows the compressor to focus more on the attack and body of the sound. I set the look ahead feature to 1 millisecond so even the quickest transients wouldn't get through. I set the parallel inject right around a 50-50 mix of the compressed and dry signals. Finally, I applied a small amount of makeup gain to match the input and output levels. Next, I'm going to move on to the snare drum. There are 3 snare tracks. I'm going to apply some compression to the snare drum top track as I'm using it for the punch and body. I'll use a similar approach here as I did with the bass drum, but I'll probably go with a heavier ratio and faster release to help emphasize the sustain. Also, I'll set the low cut in the detector circuit a bit lower since much of the body of the snare drum sound is in the 200 to 300 Hz range. I'll work with the track soloed and then check it within the context of the other drums after I dial in the sound. Here, the effect was considerably more apparent. I took off around 5 decibels in gain reduction with a somewhat heavy 10:1 ratio. I used the fastest attack possible with look ahead set to 1 millisecond and a fast release. This combination provided for a punchy sound with a good amount of sustain. I used the release control to set the sustain so it was somewhat synced with the song's tempo. This time I used parallel inject to dial the sound more toward the compressed side, and again, I applied some makeup gain to match the input and output levels. Next, I'm going to work with the ambient near channel. This stereo mic configuration is placed in close proximity to the drums and provides for a good overall roomy capture of the drum sound. Because the transients aren't as sharp on this channel, I don't need such fast compression, so I'm going to use the Grand Channel plugin, which is a TLA 100A compressor combined with the EQF 100 equalizer. I'll dial in the sound in 2 steps, starting with the compression. The goal in compressing the ambient near channel is to bring out some of the room, which will help the drum sound fuller and wider. The TLA 100A offers fairly simple operation and transparent sounding compression. I'll start by setting the low cut to prevent lower frequencies from triggering the compression. I'll then dial in the gain reduction. I'll probably go with a fast attack and medium release, as this will help bring up the overall level and make the kit sound quite a bit bigger. The TLA 100A also features a saturation knob, which is used to tame transients similar to how analog circuits do. Finally, I'll apply makeup gain. At first, it sounded like the compression was overkill, but I think it works within the context of the other drum tracks as I'm not using the ambient near channel track for any punch. The punch is all coming from the close mics. Applying a substantial amount of gain reduction of up to 7 decibels, the fast attack and medium release brought up the sound of the room considerably. I set the low cut right around 150 Hz, and I turned up the saturation knob, leaving the parallel inject dialed all the way to wet. The result is a big, fat drum sound. The downside to this is there's somewhat of a buildup in the mids. So now I'm going to use the EQ portion of the Grand Channel to scoop out some of those mids and apply a boost to the highs. I'll probably filter out some lows as well. All this should provide for a more open sound. The Grand Channel allows the EQ to be placed before or after the compression. The general rule is to apply cuts before compression and boosts afterward, as this prevents the unwanted frequencies from triggering and being brought out by the compression, and it also allows the boosted frequencies to remain untamed by the compressor. I think this EQ treatment opened up the lows and mids so the bass drum and snare drum cut better. To find where I wanted to cut the mids, I applied a substantial boost and moved the frequency knob around. I found at 470 Hz is where they started to sound muddy and boxy, so I then flipped the switch so they were being cut, and then I fine-tuned the amount. I also applied a small boost at 10K to help bring out the sound of the cymbals. I applied a low cut with the filter set to 82 Hz. Finally, I applied a small amount of makeup gain to match the input and output levels. Because I applied both cuts and a boost, I auditioned both EQ positions. I settled on placing it before the compression as I think it provided for a more open sound. Now I'm going to apply one final round of compression, this time to the drum bus, again using the FET compressor. The goal in applying compression here is to fatten up the overall drum sound while preserving the punch. One of the best ways to achieve this result is to use the All Buttons In mode, which can be activated by clicking on the label All. The result of this mode is a pumping compression with quite a bit of distortion. I'll be offsetting the effect of this treatment by dialing back the parallel inject knob. This is what some refer to as New York style compression, where a heavily compressed signal is being blended with the dry signal. Indeed, this treatment was anything but subtle, but blended in, I think it made the drums sound quite a bit bigger without sacrificing the punch. I dialed the input knob all the way up so the sound was living in the compressor. I used a fast attack and medium release with look ahead set to 1 millisecond. This de-emphasized the attack and brought up some of the room. I also made some adjustments to the detector circuit to adjust which frequencies were being treated by the compressor. At this point, the sound was very flattened and distorted. I offset this by dialing the parallel inject mostly toward the dry sound. Here's a quick comparison of what the drums sound like before and after the treatment. I think the drums sound a lot fuller and wider, but they've kept their punch. It's like a best of both worlds scenario. In the next video, I'm going to treat the bass guitar.